Hello everyone, this is Priyanshu Choubey, Assistant Professor of Soil Canberra University. Today we will going to talk about the soil organic matter and its composition and decomposition process. Soil organic matter and its composition and decomposition process. Soil organic matter consists of a complex system of a substance ranging from a components of organic residues in the decomposition, metabolic product of microbes, products of a secondary synthesis and unique substance. Serves as a soil conditional nutrient source extract of forum multiple activities. Preserve of environmental and the major determinant for sustaining agriculture productivity. The quality and the quantity of organic matter in soil depend considerably on the conditions under which the soil has developed. In arid, semi-arid, and humid tropics, and soils are low in organic matter content, except under a highly favorable condition and in highly hilly areas. In spite of its low content, the soil organic matter has a great importance in soil formation, beside creating physical and physiochemical condition optimum for growth. Um, Soil organic matter center to soil fertility and plant nutrients. Soil organic matter influence fertility in several ways. There may be a direct effect on plant growth through the production of organic compounds such as vitamins, growth regulators, etc., which have either a semestrally or inhibitors effect on crop growth. Uh, Influence on a soil fertility organic matter. In short form, we can say SOM, influence of fertility and the plant nutrient uh, is in the following ways, like humic substance impart a dark brown color to the soil, which facilitates the farming and the help in better plant growth and yield. The physical condition of the soil is that the soil structure, porosity, water holding capacity, ideal for a better crop growth, are maintained through application of organic matter. Soil organic matter acts as a reservoir for a plant nutrient and the prevent the leaching of elements which are vital to a plant growth. This is achieved by an nutrient absorption due to the high cation exchange capacity of more than 300 kilomole to proton kg per inverse. Formation of a clay humus complex through the interaction of a humic substance and clay increases the buffering and the exchange capacity of soil. Soil organic matter can form a stable complex with some metal and thus influence their availability to a plant and microorganism. Soil organic matter acts as a source of NPS, nitrogen, phosphorus, and sulfur, and micronutrients, which are vital for plant growth and are made available through the process of mineralization. The widespread and the commercial use of fungicide and herbicide and pesticide has implications on soil health and fertility. Biodegradations of this chemical through chemicals through interaction with the organic matter in the important phenomena in relation to a human and animal health. So, soil organic matter comprises an accumulation of partially disintegrated mm, and the decomposed plant and animal residues. Other organic compounds synthesized by the soil microbes upon a decay Organic matter content of a well-drained mineral soil is a low is equal to 1 to 6% by weight in the topsoil and even less in subsoil. Source of organic matter. The primary source of organic soil organic matter are plant tissues, the tops and roots of tree, shrubs, and grasses, remains of harvested crops and soil organisms. Animal and secondary sources of organic matter. Waste products of animals, remains of animal after completion of a life cycle. The role of organic matter. Organic matter creates a granular condition of soil which maintains a favorable condition of aeration and permeability. Water holding capacity of soil is increased and the surface runoff, erosion, etc. are reduced as there it is good infiltrations due to the addition of organic matter. Third one is surface mulching, which coarse organic matter lowers wind erosion and the lower soil temperature in the summer and keeps the soil warmer in winter. Organic matter serve as a source of the energy of for the microbes and as reservoirs of a nutrient that are essential for plant growth and also hormones, antibiotics. Fifth one is a fresh organic matter supplies a food for earthworms and ants and rodents and makes soil phosphorus readily available in acid soil. Organic acids released from decomposition organic matter help to reduce alkalinity in a soil. Organic acid along with the released carbon dioxide dissolve minerals and make them more availability. As a humus and highly decomposed organic matter provides a storehouse for exchangeable and available cations. Eighth one is it acts as a buffering agent which checks rapid chemical change in pH and soil reaction. Specific types of uh, soil organic matter substance and pools. So non-humic substance, humus, and soil organic matter pools, um, partitions, and soil organic matter decomposition rates. Non-humic substance, uh, uh, various humic substance. A non-humic substance most easily decomposed make up to 10 to 15% of the total soil organic matter. Non-humic substances have variable resistance to a chemical and biological degradation in a soil and can be broken down further. They exist mainly in levy soil organic matter pools and are not components of humus. Humic substance stable resistant to a decomposition make up to about 85 to 90 percent of the total soil organic matter. Humic substance where resistance to a chemical and biological degradation in a soil and parasite mainly in a long term soil organic matter pools because they do not break down of other they are component of humus. Organic carbon or nitrogen phosphorus sulfur ratio and a plant ratio. Carbon is present in the form of organic matter or a humus. The carbon content varies from 1% in the porous texture soil in a 3.5% in the grassland soil. Poor drained soil in a general contain a 10% or more carbon. The tropical soils are very low in organic carbon. Organic carbon is closely related to a nitrogen content in the surface soil. Most of the nitrogen is in the organic form. The CN ratio between a 10 ratio 1 and 12 ratio 1 in an ideal soil. Several factors such as a topography and drain parent material and vegetation influence the levels of soil organic matter. Organic matter extracts a substantial influence on the crop production can and soil properties. Soil rich in humus are generally more productive. Humus high humus has high cation exchange capacity. Humus has a high cation exchange capacity, 30 to 70% of the total, which hold a nutrient ions which like potassium, calcium, magnesium, zinc, etc. in an exchangeable form. The nutrient and organic matter interaction in the soil create a favorable condition for improving soil fertility. As like the plant and animal residues upon a degradable provide nitrogen, phosphorus, and sulfur and micronutrients. Microbial biomass serves as storage units of nitrogen for a time varying from a few months to several years. Conservations of the organic nitrogen, phosphorus, and sulfur to available forms occur through activity of a microorganism and the rate of the conversion through a mineralization influenced by the factor affecting microbial activities such as the temperature, moisture, pH, and content plant residues. So organic nitrogen, phosphorus, and sulfur convert to in organic form. It's a mineralization process and a mineral inorganic material inorganic content are converted into organic form. It's immobilization. So through there a variation in the properties of this nutrient is a different soil has a C and P S ratio of soil humus at 140 to 140 ratio, 10 ratio, 1 ratio, 1.3 and 1.3. So carbon nitrogen ratio of legumes and the young green leaves range from a 10 ratio 1 and 30 ratio 1, while it is the high as a 600 ratio 1 for a sawdust. The carbon-nitrogen ratio of a bacteria, fungi, and actinomycetes range from a 5 ratio 1 to 10 ratio 1, and for a cultivated soil is range is at 8 ratio 1 to 15 ratio 1. The carbon-nitrogen ratio is lower the subsoils than the surface soil. The carbon-nitrogen ratio for the particular soil is one of the characteristics the equilibrium values. These values are important for two reasons. First one is when by the carbon nitrogen ratio organic residues are added, there is a competition among microorganisms and the plants for available soil nitrogen. The maintenance of the carbon soil organic matter is depends on the level of the nitrogen. So if large amount of fresh organic residues with wider carbon nitrogen ratio is greater than 30 ratio 1 are incorporated in the soil in the hetero heterophyte microorganism becomes active and increase their population. With with the introduction of more carbon dioxide through their respiration under this condition, the nitrogen levels is soil decrease. As the microorganisms utilize the native soil nitrogen, nitrogen is immobilized at the initial stage and is not available to plants. Hence, a basal application of nitrogen through inorganic fertilizer made to meet of nitrogen requirement of crop as the decomposition process the carbon nitrogen ratio and organic matter decrease with loss of carbon and conservations of the nitrogen at given point time. Addition of plant residues with a higher carbon nitrogen ratio and carbon phosphorus and carbon sulfur ratio favorable. Initial net immobilization followed by a net mineralization and the large stage residues with a lower ratio for favorable the mineralization. The difference in the release of the nitrogen, phosphorus and sulfur from soil organic matter is due to several reasons. The reason nitrogen, phosphorus, sulfur do not occur in the required ratio as this the present in the different organic compound and organic matter frictions and the degradability in is a different for a different compounds. The carbon, nitrogen, carbon, phosphorus, and sulfur ratio of a plant's residues regulate the mineralization and immobilization of nutrient at any given time. The actual amount of the nutrient released shall not be made available to a plant as this subjected to loss or fixation in a nitrogen. So carbon cycle and carbon stocks the carbon global carbon cycle stocks carbon stocks in Indian soil estimate the carbon organic matter stocks are major soil types of different agroecological sub-region of Indian soil has been uh, the low content of the soil organic matter organic carbon in Indian soil has soil has been the attributed to excessive tillage and imbalanced fertilizer use, removal of crop residues for field soil degradation, and the prevalence of a tropically arid and semi-arid climate condition. Soil organic stock that soil organic carbon, soil inorganic carbon, and a total carbon TC is seven different soil order in India. Soil show that the vertisols, insectisols, and alphisols have a major share carbon soil organic carbon stock in a surface 0 to 30 centimeter soil depth. For similar data, arid soil shows a very low and a very high level of sick stock. The arid bioclimatic system is characterized by the low annual rainfall of 500 sick stock. The arid bioclimatic system is characterized by the lower annual rainfall, less than 500 mm. Since these areas do not support dense vegetation, the soil are low in organic carbon. Um, anti carbon stock in an ideal soil order while anti-soils and vertisol, insectisol, arid soil and molly soil, altisol. So different types of soil order having a different types of carbon stocks and the soil organic carbon and availability depth, soil depth. Soil organic and organic carbon stock in commonly found in Indian soil 0.30 centimeter soil depth, like organic and organic total. So alluvial soil having the soil organic at 2.79 and black soil 2.56 and arid soil having a 0.71 and brown forest soil in 0.12. That soil having a 3.33 and total carbon carbon available in Indian soil 9.55. In organic alluvial soil having a 1.52, black soil 1.08, arid soil having a 1.39 and brown forest soil having a 0.0 and red soil having a 0.15 and total inorganic stock available in 4.14. Estimation of a soil organic matter. Soil organic matter content is determined in the soil testing laboratories in rapidly titration method Brockley and Black 1934. In this method, known as amount of the soil is oxidized with the mixture of the potassium dichromate and oxidized with mixture of a potassium dichromate and concentration sulfuric acid. Utilizing the heat of dilution, utilizing a heat of dilution H2SO4, unused potassium dichromate is the black titrate with a ferrous sulfate or ferrous ammonium sulfate. Uh, Soil organic matter content is calculated by multiplying soil organic carbon content with 1.724. Soil organic matter contain an average 58% carbon, so that 100 by 58 soil are also closely related. Carbon nitrogen later soil organic carbon is related as a low is less than 0.5%, medium is 0.50 to 0.75, and high is more than 0.75. Constituents of the soil organic matter. The major source of soil organic matter includes various plant tissues such as top and roots of trees, shrubs, and grasses. Animals are harvested crop soil organic animals, uh, and the waste products of the animal remains of the animals after the completion of a life cycle. Life cycle, the organic compounds in the plant tissue can be arranged into broad classes such as cellulose, hemicellulose, hemicellulose, and protein, lignin, and etc. The elemental composition of these compounds is carbon, oxygen, hydrogen, and ash. Thus, the composition of organic compounds in the soil result in the production of the carbon dioxide, water, biomass, and energy. Uh, Mineralization of organic nitrogen, phosphorus, and sulfur compounds and release of nitrogen, phosphorus, and sulfur in organic form as for uptake by a plant. Formation of a compounds which are resistant to a microbial activity. The approximate properties of the organic carbon form the plant residues that are found are unique and non-unique substance. 1 year after the addition of a reduce or reduce much of the carbon is returned to the atmosphere as a carbon dioxide, but nearly one third remain in the soil mm, either in a living organism for 5% and a humus for 25%. The percentage distribution of different composition in the soil organic matter and type of material and usual range percentage by a weight. Non-humic substance lipid having a 1.6 percentage carbohydrate 5 to 25%, protein peptides and amino acid having 9.16% and other trace. Humic substance 80%. On the non-unique groups that comprise the organic substances which are well defined chemically and usually colored. Most of these substances are simple low molecular weight compounds which can be utilized as a substrate for biosoil microbes and have a transcribe and accidents in the soil. Humic acid are among the most widely distributed organic materials on the earth. They are found not only in the soil but also in the marine and lake sediments and peat bogs and compost natural water, sewage, carbon shells, ground coals, and nucleus deposit. The total amount of carbon in the earth as a humic acid is estimated at 550 gram in a higher than the land biomass carbon 400 to 40 gram. Pool of the soil organic matter. Organic matter in the soil can be partnered into a different forms or pools. The size of the individual pools are varies seasonally and is depend on the features as the soil, type, vegetation, and climate. And the concept of a pool of organic matter that differ in their uh, susceptibility to microbial decomposition and their longevity in a soil provides the basis for the understanding and the dynamic nature of the soil organic matter and how a nutrient availability, nitrogen, phosphorus, and sulfur and trace elements in the influenced by the management practices and change in the soil environment, the pool of organic matter as like liter it refers to a macroorganic matter like a crop residues, residues that lie on the crop surface. This pool is important in the cycling of nutrients in forest, soil, natural grassland, and the crop production. Agriculture, increasing attention is now being given to a cropping system where the residues are allowed to remain on the soil surface following a harvest, such as in a conservation tillage or a zero tillage. The light section consists of organic residues in various stage of a decomposition that exit visit within in the soil. Root residues make a major contribution to the friction and particularly in a perennial system. Friction has been used as an indicator of a change in the lively organic matter affected by a tillage, dropping particles in the environment factors and affecting microbial. Microbes play a dual role in the soil. Firstly, they act as an agent for a degradation of plant residues with a contaminant release and nutrient and the carbon dioxide. Secondly, serve as also a liable pool nature. The size of the microbial biomass carbon may account for 2% of the total soil carbon. Uh, Fuel biomass in a general soil in a particular soil microfauna such as the nematodes and microscopic insects and the mites have not been studied as intensively and extensively as a soil microorganisms are an acceptation as they are the most widely studied soil uh, invertebrates in many cases soil fauna have been studied uh, on the population basis rather than a biomass basis and hence it is difficult to make a direct biomass comparison with the group of organisms. Population of the groups are affected by the management practices and season of the year. Below ground plants constitute this part given importance particular for the below ground compounds such as root, water soluble or organic. So water-soluble organic matter has received much attention, particularly from the standpoint of the plant nutrients and the environment, metal ions, toxicity, chelation, and acidic, acidifying effects on natural waters, and the carries of the nature water and carries of the antibody antibiotics. Stable humus in the most of the soil bulk or the soil organic matter occurs as a stable humus. Both chemical and physical fixation procedures have been used to separate and various components of humus and as certain they are a location within the soil matrix. Soil enzymes are a quantitatively minute. This constitutes a very important section of a soil organic matter because of all biochemical reactions depends upon or related to them because of their complexity and variety of a substrate that serve a energy source of the microorganism, the soil would be expected to contain a wide area of enzyme. Each soil may have a own characteristics pattern of a specific enzyme. Certain enzymes are enzyme or ubiquitous that is they are found is virtually all of the soil and typical example are catalase and phosphophosphates and the pep, peptidase of a various type or other enzymes may be produced in the soil only under a especially uh, circumstance dehydrogenase activity appears to be related to the quantity of decomposable organic matter and is closely related to the soil biomass. Stevon or coal 1990. Extraction, fixation, and the characterization of soil organic matter. Extraction and fixation. The large number of extraction have been used to recover organic substance from the soil. The soil organic matter extract from the soil using a reagent like zero point 0.5 normality NaOH and the 0.1 molarity sodium pentoxide is usually frictionoid on the basis of a solubility characteristics. Sequential friction scheme the outlined in is used to get different frictions for organic matter. The soil organic matter is subdivided into three classes: humic material, fulvic Fulvic acid, which is soluble in the alkaline and acid soil. Humic substance, which is soluble in a alkali but insoluble in acid soil. Human so insoluble in the both alkali and acid. The other fixation include the Hamartomalonic acid, the gray and the brown humic acid. It is the emphasized that the fulvic acid and humic acid and humin are not the compounds of the defined chemical composition, but are the group of the compounds having a similar solubility characteristic. The percentage of the humus and the fat in the various humic substitution vary considerably from one soil is another. Algae soil and the spodosols and algae soil generally have lower humic acid and phosphoric acid ratio than a humus of a pit and the grassland soil molly soils. The forms of humus is the four soil orders are the illustrated in humus of a molly soil is somewhat richer in humic acid of other soil humus offers further soil or the enrich the components associated with pelvic fixation are unique feature of the vertical soil with higher content of alkali insoluble organic matter like a humic. The humic structure strong basis strong basis NaOH 80% and Na2CO3 is 30%. Hydro hydroaldehyde compound sugar polysaccharides play found. Human fixation the human fixation is that the portion of soil humus remain behind after the extraction of soil with a dilute alkali. The human fixation may consist of a humic acid, so immediately bound of mineral matter like a flake that the two cannot be separated. It may have been a highly concentration humidified. Humic matter with a high carbon content more than 6% and therefore is soluble in alkali and also contain a fungal melanine. Humic acid friction extracted from the soil with the alkali and neutral soil are precipitated under a acidic condition. Uh, Including humic acid from a grassland soil appear to have especially high ash content, often exceed 30%. Considerable reduction in ash content can be achieved by a repeated precipitation with the mineral acid and by a phases through ion exchange resin. The effective way for removing clay is by speed centrifugation after re-dissolving the humic substance acid in a dilute clay and adjusting the pH 7.3. Humic acid with a low ash content can be obtained by a treatment in a acid solution containing humic humic acid. The transferred humic acid humic acid material is the first dissolved in the base on the ionic strength is as strict to 0.1. normality with respect to the PCL, and the sample is centrifugated to a remote place. The solution is acidified to precipitate a humic acid, and the sample is treated several times with the dilute acid solution consisting of 2.3 normality. Humic, humic the sample is digested extensively against distillate water and fridge the filter to ensure the removal of the metal ions or a sample can be just in the presence of the cation exchange rising or hydrogen bonds. The effectiveness of the chemic friction in the reducing the ash content, the unique acid is based on its availability of dissolved hydrate clay minerals and to form a complex with the dye and the trivalent cation. The reduction is the as cation is accumulated by the loss of a unique matter, possibly by the liberation of the low molecular content is accompanied by the loss of the unique material, possibly by the through metal language.